Hi, welcome back. So let us now continue our discussion regarding the physical attributes of AB material. So this time we're gonna focus our discussion on size. Okay, so when we say size, it is actually the measurement of dimensions. Okay, so let's have some examples of our AB materials here. Say we have a uh, say this is a rice straw, and say we have fruit like uh, like what's this? Say we have this watermelon. Okay. Okay. What else? Um, let's have another fruit like mango. Okay. So this is our mango. Okay. So this tree is an example or are examples of our AB materials. So we can see that. Okay. So as you notice, the three different AB materials has each own sizes. Okay. So what can you say about the size of the straw? About the dimensions or the measurements of this rice straw? Okay. How about the watermelon and as well as the mango? Okay. But uh, if we analyze this regarding the size, in maybe some of it is we can easily specify the size of that particular AB material. Okay, especially if we have a um, regular particles or if we have a regular shapes of our material. Okay, but for irregular particles like this one, like for the mango, so as you can see we have different curves and asymmetry uh, features of the mango fruit. So we cannot easily say what is the size of this mango. Okay. Okay, so since we say that size is the measurement of dimensions, then how can we really measure the dimensions of the AB materials? So we have methods on how can we measure directly the dimensions of the AB materials. Okay. Some of the methods are this. So we have methods. We can use the vernier caliper. Caliper. Yeah. Actually, we have instrument that is called a vernier caliper. It measures least count of 0.01 cm. Okay. So if your material belongs to this count, then you can use the method vernier caliper wherein you will use the instrument vernier. Okay, we have also the what we call the micrometer method. Okay, mm. And as you can see, if you have an AB material that the least count is around 0.01 millimeter, which is smaller than the particle size uh, of Vernier caliper method, then you may now use the uh, micrometer method. Okay, we have also the what we call micrometer to measure the dimensions of that AB material. Okay, so imagine what kind of AB material is that. If you have a least count of 0.01 mm, so maybe a very small particle. Okay, so eh, if we compare these two, we can notice that the micrometer can measure a smaller particle than the vernier. Okay, we have also um, the what we call projection method. Traveling microscope, and Shiv analysis method. And we have also the what we call projected area method. Okay, we see that we have many methods on how we can measure the dimensions of the AB materials, but the dimensions that we're gonna use will be based on the projected area method. Okay, sorry. Okay, let's further discuss this projected area method. So, size can be determined using this method. Projected area method. Okay. But before we start to determine the dimensions using the projected area, let's first define the three characteristics dimension, the three characteristic dimension. Okay. So these three characteristic dimensions are the what we call the major diameter, the intermediate diameter, and the what we call the minor diameter. So basically, these three characteristics dimensions are the what we need in order for us to determine the size according to a PA method. Okay, so the major diameter, this intermediate diameter, and the minor diameter is we commonly known this as the this is the length, the width, and of course the thickness of our AB materials. This major diameter here, or the length, diameter or length, is defined as the longest dimension of the maximum projected area. Okay, so let's define the tree first, then I will illustrate it later. While the what we call the width or the intermediate diameter is the maximum diameter of the minimum projected area or the minimum diameter of the maximum projected area. Okay. And lastly, the minor diameter or the thickness is the shortest dimension of the minimum projected area.